Okay, so q of t is given as 100 minus 10 root t, where t is the age of a person in years. So we're asked in part A to find q of t when t equals 0, t equals 25, and t equals 100 years. So q of 0, well, we just substitute 0 in, we get 100 minus 10 root 0, which is equal to 100. Same thing for q of 25. That gives us 100 minus, and then 10 times the square root of 25, which is 5, which is equal to 100 minus 50, which is 50. Then with this third part of this subpart, q of 100, is 100 minus 10 root 100, which is 100 minus 100, which is 0. So wait, let me just write that out. 100 minus 10 root 100, which is equal to 0. Okay, and now we're on to part B. So at what rate is the quantity of the chemical changing when the person's aged 25 and 50 years? So what we have to do is differentiate the function in order to find the rate. So q of t, let me just write this all in terms of powers because it's easier to evaluate a function that way. So q of t can also be written as 100 minus 10 times t to the power of half. And now we're ready to differentiate. So q prime of t is equal to, then 100 goes away, but so now we just differentiate this part, and we get minus 10 times half times t to the power of negative half. We decrease the power by 1, which gives us negative 5t to the power of negative half, which gives us negative 5 over root t. Oops, the t doesn't look so good. T. Now we're on to the easy part. So we just find it when t is 25, so we get negative 5 over, let me just write out t equals 25 years. So the rate is negative 5 over root 25, which is equal to negative 5 over 5, which is negative 1. That's the rate, so negative 1. And for part 2, t equals 50 years. We get negative 5 over root 50, which is equal to, can that be simplified further? Yes, it can. It can be written as negative 5 over 5 root 2, which is equal to negative 1 over root 2 as the 5's cancel out, which is equal to negative root 2 over 2 when we rationalize the denominator. So that's our answer.